All right, going to do the 710 notes, and I'm going to do a little bit of stuff that's not included in your notes. Your note outline should look like what's on the screen here, but I'm going to kind of start up here. And I just watched this part. I'm going to try to go pretty fast. I drew out a couple of similar figures here, and in these top two examples, we start with a 2 and a 3, and I go to a 4 and a 6. So how much did that change? That's going to be a scale factor of 2. So I'm going to write a SF equals 2. And again, you don't need to write this stuff down. For the bottom one, I have a 2 that gets changed to a 6 and a 3 that gets changed to a 9. So I multiplied each of those by 3, so it's going to have a scale factor of 3. Now I want to look at what happens to the perimeter and what happens to the area as we do this here. So if I look at the perimeter of this first object, my distance around is going to be 2 plus 3 plus 2 plus 3, which gives me a perimeter of 10. And if I go and do that same thing, excuse me, for my other triangles, 4 plus 6 gives me a perimeter of 20. And then if I go and look at the ones down below, I'm going to have that same initial perimeter of 10, so perimeter of 10. And 6 plus 9 plus 6 plus 9 gives me a perimeter of 30. So my question is, how does the scale factor impact how you get from one to the other? Well, it looks like 10 times 2 gives me 20. So let's see if that works for the second one. 10 times 3 gives me 30. Okay, so one of the equations I want to write down then is going to be that this new perimeter, the perimeter of something after a scale factor, after a scale change, size change, is going to equal the original perimeter times the scale factor. So if we jump down to your notes, we want to write that. So I'm going to put it in red for dramatic emphasis. The new capital P, the new perimeter, equals the original. I'm going to abbreviate it ORIG, period. Original perimeter times the scale factor. And I'll maybe do SF for scale factor. And I'll maybe do a little arrow and say scale factor. This equation here comes in really handy if you're trying to find either the new, if you're trying to find the new perimeter. Sometimes, though, you'll be asked to find, well, what's the scale factor? So we could take this equation and get scale factor by itself. Well, scale factor is multiplied by the original perimeter. So if we divide this side by original perimeter, divide this side by the original perimeter, we'll have a equation that says the scale factor equals the new perimeter divided by the original perimeter. So if you're getting a question that says, hey, what's the scale factor when you have this perimeter originally and then this one in your new, this equation will be a little bit easier, but both would work. All right, I want to jump up to the thing above and quick do one more little bit to it. If we were to look at the areas of these, area is base times height, so I'm just going to quick throw in the numbers. Area here is 6, area here is 24. And area down here will be 6. And area here is going to be a 54. All right, so now, does that work the same way? Well, no, because 6 times 2 doesn't give me 24. I have to do a 6 times 4. So it looks like, well, doubling this would work, because then 6 times 2 times 2, 6 times 4 gives me 24. But does that work down below? Doubling this gets me a 6. 6 times 6 is only 36, not my 54. But instead of doing 2 times 2 and 3 times 2, if we look at it as though we're squaring each of those, that's still 2 times 2. But now this one becomes 3 times 3, or 3 squared, which is 9. And 6 times 9 does give me 54. So in other words, what we just found is if we're looking for this new area, it's going to equal my original area times the scale factor squared. So I could go back to my other page and write that in there. So I'll get back to my other page. So here's our second equation. Then we'll go through and do some examples. So the new capital A, the new area, equals the original A times the scale factor squared. And I'll maybe put SF there in parentheses just to show that it's not F squared, but that it's the whole scale factor squared. And now this one, if we're going to solve for the scale factor, that gets a little bit weird because we do need to divide by the original A like we did before. And that'll give me my scale factor squared. So I'm going to write it this way. I'm going to say my scale factor equals the new A, the new area, divided by the original A. But we said that this here gave me scale factor squared, and I wouldn't write this in, but I don't want to know what my scale factor squared is. I just want scale factor. So if you think back to how do we get rid of squares before? We did square roots to both sides. And essentially when we do that, what happens is this square root just cancels out the square, giving us the scale factor. So you could fill in, write what this is if you wanted to. Scale factor, or I would write it, scale factor equals the square root of the new area divided by the original area. Now I want to make one comment because the book refers to these things here, these fractions. So this fraction right there, the new perimeter over the original perimeter, is called the perimeter ratio. And I would write that down if I were you. You're going to get some questions that say, what's the perimeter ratio of these similar figures? In which case, just do the new perimeter divided by the original. And this fraction here, now it's not the square root of it, it's just the fraction. You could say the fraction here, instead of being the perimeter ratio, the fraction is going to be the area ratio. If you think back, the ratio is just a fraction, so that kind of makes sense of what we did before. Right, now we can take those equations and try to quick go through a few examples. So this first one's looking at area, so I just need those bottom two equations. And it says if an artist's print gets enlarged by a scale factor of 4, what will be the new area if its original area was 32 inches squared? So it's looking for what's the new area, that's what it's asking for. What will be the new area? So to get that to work out, this equation here is going to work best. So I'll write that down. New A equals the original A times the scale factor squared. All right, so the original A is 32. Next part about writing the equation is now you can just plug and chug. Original area is 32. Scale factor is 4, so I can put my 4 in there and square it. Now I just type in 32 times 4 squared, and that gives me 512. So 512. Technically, this is like inches squared here, and the scale factor doesn't have units with it, so it'll be 512 inches squared, or 512 square inches is the new area. All right, you can do similar down here for perimeter. Perimeter, what's the new perimeter? So going back to our equations, that upper left one is solved for new perimeter right here. So that'll be our easiest one to use. So I could write new P, new perimeter, equals the original perimeter, original P, times the scale factor. Please show your work, makes it so much easier. So the original perimeter is 24 inches, so I could put that there under original P. And the scale factor is 4, so I put that in there. And there's no squared, so I can just multiply it. And that gives me 96 inches. It's going to be that new perimeter. Example 3 is going to use one of those same equations a little bit differently. Let's take a look. If the area of a new print is 82 square centimeters, and the scale factor is 3, what's the area of the original? Okay, so we're looking for the area of the original, so we can go back to this, and we're going to either have this equation or this equation. So is it easier to find this number, area of the original here, or here inside the square root? I would argue probably this one. So I'm going to copy down that equation then, and we have the new area equals, so new A equals the original A times the scale factor squared. Got to remember to square that scale factor for area. All right, now we can just plug in our numbers because we're using the equations, doing it the easy way. So 82 equals, scale factor is 3. We have to square that. We're trying to find that original area. I'm just going to put an X in rather than go and write the whole original area. So I get 82 equals X times 3 squared is 9, so I'm going to do that first. All right, now we want to solve for x. So we just say, well, x was multiplied by 9. We have to do the inverse of that to find what x is. And 82 divided by 9 gives us 9.1 repeating. So x, the original area, equals 9.1 repeating. And if you want to do the really fantastic job, you go and say, all right, so the units were square centimeters for the new area, so it'll be that same, it'll be 9.1 centimeters squared. 2 examples left. All right, what's the scale factor if similar figures have a perimeter ratio of 25? So I'm going to jump back up to the top. And you'll remember that we said this fraction, this ratio here is the perimeter ratio because it has perimeters in there. We called this the area ratio. So they're giving us this fraction. They said the perimeter ratio is 25, I think. So we could take and make the math easy. Let's show our work. So scale factor equals the new perimeter divided by the original perimeter. And sometimes you'll have to actually put in the new perimeter and the original perimeter, but we were just told that that fraction, that ratio, is 25. So you can put 25 in for that fraction. So what's the scale factor? Well, the scale factor equals 25, and we're done. So that's example 4. If we flip the page over, it's going to be the same exact thing, but now it's looking for, they give you the area ratio. So if we were to copy that equation from the top of the last page, we said the scale factor equaled the square root of the new A over the original A. Okay, so now the area ratio, well, that's going to be that fraction right there, that new area divided by original area. So we could put a 64 in for the fraction. We have our scale factor. But the scale factor isn't 64. It's the square root of that ratio, or the square root of that fraction, or the square root of 64. So if we're trying to find the scale factor, the square root of 64 is 8. So then this would have a scale factor of 8. And that's it for the section. Let me know if you're stuck on something. I'd be glad to help you. And have a great day.